What should procurement teams verify before choosing how to choose a pulse welding machine for stainless steel vacuum flask bottom welding? The answer is not just speed. Buyers need to check whether the solution fits real production targets, delivers stable data, and reduces downstream risk for quality control, maintenance, and supplier coordination. This walkthrough focuses on the practical evidence a buyer should request before moving forward with a purchase decision. A 4-part selection matrix links 7 verification checks to bottom weld stability, spatter control, and line compatibility for flask factories. Bottom welding is a small step in the visible product, but it is a major control point in stainless steel vacuum flask manufacturing. The bottom joint affects sealing confidence, downstream surface finishing, production rhythm, and the amount of rework that appears after a batch has already consumed forming, cleaning, and handling time. For this reason, a pulse welding machine should be evaluated as process equipment, not as an isolated electrical unit. A suitable machine for this application normally combines controlled discharge, repeatable pressure, fixture stability, adjustable parameters, and supplier support for trial welding. Capacitive energy storage welding is often considered because it can release a short, controlled pulse for metal joining. The practical question is not whether the machine can make a weld on one sample. The stronger question is whether it can keep weld appearance, penetration, and repeatability within the factory standard across bottle sizes, operators, shifts, and maintenance cycles. What bottom welding requires in stainless steel vacuum flask production. 1.1 Common bottom welding tasks in bottle and flask manufacturing in a vacuum flask line. Bottom welding may involve joining a base disc, closing a bottom structure, or preparing a lower joint before later vacuum and finishing operations. The joint has to tolerate handling, cleaning, polishing, and inspection. If the weld is inconsistent, the effect may not be limited to the welding station. A weak bottom weld can increase leak risk, cosmetic defects, and the number of pieces that return for grinding or repair. 2 Material and structure factors. Stainless steel bottle bodies are often thin enough to be sensitive to heat input, but rigid enough to require firm contact and stable clamping. Double wall bodies, tumblers, cups, and flask bottoms can differ in diameter, thickness, edge geometry, and fixture requirements. The equipment therefore has to manage more than power. It must hold parts in the correct position, deliver repeatable energy, and allow engineers to tune parameters for material and geometry rather than forcing every product into one fixed setting. 2.1 Why weld stability matters before finishing. Weld stability matters because post-weld finishing does not solve every welding defect. Polishing may improve appearance, but it cannot reliably correct poor contact, uneven penetration, or excessive heat distortion. A factory that treats bottom welding as an upstream quality gate can reduce hidden cost later in the line. What type of pulse welding machine is suitable? 2.1 Capacitive energy storage welding as a practical option for stainless steel flask bottom welding. The suitable pulse welding machine is usually one that uses controlled stored energy, supports adjustable welding parameters, and can be matched with purpose-built fixtures. A strong buying decision depends on more than a good brochure. Teams should compare measurement range, repeatability, calibration method, sample preparation requirements, maintenance support, and evidence from real plant use. When those checks are completed before purchase, the business can reduce retesting, avoid production delays, and choose equipment with more confidence.